Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and the question belongs to paper 9709/41 for the session May June 24. Let's read the question. Question number 3, which says a train of mass 180,000 kg ascends a straight hill of length 1.5 kilometer, inclined at an angle of 1.5 degree to the horizontal. As it ascends the hill, the total work done to overcome the resistance to motion is 120,000 kilojoule, and the speed of the train decreases from 45 meter per second to 40 meter per second. Find the work done by the engine of the train as it ascends the hill, giving you answer in kg. Well, this is a very interesting question because look, the question itself has suggested us to apply the concept of work energy equation. Look, they have written here that the done to overcome, here look at this, work done to overcome the resistance. That means indirectly they have advised us to apply the work energy equation. So before moving on to the solution, let's have a sketch of the scenario, and that is, look, this is the hill, okay, inclined at 1.5 degree to the horizontal, and this is the height, okay, this is height, and here the angle is 1.5, 1.5, 1.5. Let me write properly, 1.5. Let me sketch a larger figure. Yes, a little bit larger so that my stylus work well. So this is 1.5 degree is the inclination. Well, and this one is height of the hill, and the length of the hill is given 1.5 kilometer. But remember, kilometer should not be the unit while solving the solution. The standard unit of length is meter. So we have written it in meter. And the weight of the train is 180,000 kg. So as we have already come to know that we are going to apply the concept of the work energy equation. So what is the work energy equation? The work energy equation is work done by driving force minus work done by resistance force is equal to change in GPE plus change in KE, means kinetic energy. That means change in gravitational potential energy and change in kinetic energy. So let's start the solution. Work done by driving force is to be obtained, so it will remain unchanged, and work done against the resistance force has already been mentioned, which is, here it is written, 1200 kilojoule, not 1200, 12,000 kilojoule. So kilojoule should not be the unit of our work. The standard unit of work is joule, so let it be converted into joule. It is going to be 1200, 120, 100,000. That means how many zeros will there be? Already there are three zeros, then three more zeros should be added, so it is going to be 1200,000, no, not 1200,000, 120, 100,000, 120, 100,000 joules. Well, equal to change in GPE. You know the formula of change in GPE is what? mgh, mgh plus change in kinetic energy is half m v square. Well, so let us apply the values. Or work done by driving force is equal to mgh. M indicates the mass, Mass of the train was 180,000. 180,000. 180,000. After 180, there will be three zeros. Into acceleration due to gravity is 10, the value of g is 10, and height. We have already decided that height is this one. So how to find height? Height is actually 1500s, and this is hypotenuse. Don't forget the concept of the Pythagorean theorem. From the Pythagorean theorem, using a right angle triangle, we can find the height. So height is equal to 1500 sine 1.5 degree. 1500 sine 1.5 degree. Let it be written 1500, which was the hypotenuse. 1500 sine 1.5 degree. Well, this is mgh. Then plus half. M stands for mass. Mass has been given at, let me write just below this, plus half. M stands for the mass of the train is 180,000. 180,000. After 80, there will be three zeros. 180,000. Then v square. Here there is a crucial point. Remember, whenever we write v square, final velocity should be written first of all. So final velocity, look, the velocity decreases from 45 to, let me show you, erasing this overwriting. Yes. Now just have a look at this. The train speed of the train decreases from 45 meter per second to 40 meter per second. So always remember, it's a very crucial point, as we have used plus symbol in front of half. So the final velocity should always be written first. And here final velocity, what was the final velocity? Final velocity was 40 meter per second. So 40 square minus 45 squared. 45 squared. Let's move on to the next step. Work done by driving force is equal to, yes, there is something missing. We didn't write this, look, this portion. This from the left side, 120 100,000 should be also written as addition. From left to right, if we transpose, it is going to be 120 100,000. 120 100,000. One more zero. Well, so in our left side, there remains nothing but work done by resistance force. Let me go downward. Yes. So on the left side, there is nothing but work done by resistance, work done by engine, work done by driving force is equal to, if we multiply 180,000 and 10, it is going to be 1800,000. 1800,000. That means how many zeros will there be? 4, 5. 1800,000 into 150 sine 1.5 degree, plus, if we dissolve 180,000 by 2, it is going to be 90,000. 90,000. 90,000. Then there is one more thing should be noted here, that it is going to be actually negative. Look, here between 40,000, 40 square and 45 square, greater one is negative, so the symbol will be actually negative. So negative 90,000, negative 90,000. 90,000. 40 square minus 45 square, it is going to be, 40 square means 1600, 45 square means 2025. So it is actually 425. 425. After that, there comes plus 12,000, plus, not 12,000, it is 120 100,000. 120 100, then 1000. Well, so let us calculate this. Work done by driving force, work, hence work done by driving force, hence work done by driving force. No, that should not be the final stage, because they have told us to express in kilojoule. Work done by driving force, let me calculate, let me use my calculator. First of all, there is 18,000, not 18,000, 180, 100, 1, the 1800,000 into 150 sine 1.5 minus 90,000 into 425 plus 1200,000 is equal to 4 4 triple 4 27 760 joule. But they have told us to express the quantity in kilojoule. So if we divide it by 1000, it is going to be, what will it be? Just before here there will be the decimal point. Before what? Before the second 7. So it is going to be triple 427.76 kilojoule. Now, one more information should not be forgotten by us, which is we should express any quantity in three significant figures. So, if we express work done by driving force is equal to triple four. Now, these are the three significant figures. What about this? As this is less than 5, so it will be just 0. How many zeros? Two zeros. So, triple four, and that means 44,400 kilojoule. I think you have got this answer. This is not complicated at all, but you may get confused in the information here. So please remember that it should be here. Yes, here always the final velocity should be written at the beginning. So thanks all for watching the video. Let's move on to the immediate next solution. Allah Hafiz.